Welcome to qnawire.
So here for part A, we can say that the average acceleration for each interval would be calculated by the average acceleration equaling delta v divided by delta t. And we can say that, and this is going to be taken to be the acceleration at the midpoint of any time interval. So we can say in the spreadsheet, we can say that a to the n plus 1/2 would be equal to v to the n plus 1 minus v to the n divided by t to the n plus 1 minus t to the n. And so we can, the second workbook has the accelerations. However, this would be the formula that you are going to use for part A. For part B, however, we need the position at the end of each interval, and this could be equal, this would be x to the n plus 1, so the next interval essentially would be equal to the initial position at the nth interval plus 1/2 times v to the n plus v to the n plus 1, so the next velocity in the data set, and then t to the n plus 1, again, minus t to the n. And we can also represent this as x would be equal to x initial plus the average velocity times delta t. However, you want to use this equation because this is obviously much more specific. And tabulated, it would look like this. So these would be the time with the average, with the velocity in kilometers per hour and the velocity in meters per second. Again, we know that 1 meters per second is going to be 3.6 kilometers per hour. And we know here it would be t in seconds. So this would be for A, and these would be for B. And then for part C, they wanted you to graph the acceleration versus time and the distance versus time. And these are what the graphs would look like. You can simply put the data set into Excel and then obtain a graph that way. That is the end of the solution. Thank you for watching.